All right, so this is part 2. I'm not sure if I'm online on everything. Let's just wait for it to come up. If it comes up, just to make sure we're broadcasting live on all 3 channels. So I'm trying to broadcast in Twitch, YouTube, and custom RTMP, which is Facebook. And that doesn't seem to be working well. Let's see. All right, not sure if I'm live. We'll find out. It's my first live stream, guys. So, well, first second live stream. So trying to connect. Hi, all right, so we're live on all 3 channels, Twitch, YouTube, and Facebook. So this is kind of like part 2 of the my first ever live stream, or my test live stream, where I'm doing a live game jam. Well, hopefully parts of it. So we've got, where did we leave off? All right, so my bad for the previous live stream, where I shouldn't have been using a source build for live streams because of all the long compiles. Should have used a binary build off the engine, which I've moved it. I've moved to a binary build, still 418 now, and I'm gonna have to move that to a custom build. So this is what we're doing: is live game jam, and I'm just trying to use this game jam as a platform to actually do tests on live streams. So I want to do a VR development series for Unreal Engine 4. And yeah, so I've done at the beginning to create a GitHub repo, connect that GitHub repo, add not a sub-module. I understand you could create sub-modules, but that's always been a problematic for Git. So I've created a secondary repo from within a repo into the project. So let's just go over it quickly. So, oops, in OpenJam 2017. So that's a repository here, and inside the plugins, my VR plugin is another repository here. Okay, and then I created a branch for that for this, just in case I need to change any of the code. I've made a basic C++, well, a blank C++ code, and we were doing a compile. All right, so the compile is finished, and we have failure here, and we're just gonna have a look at what it is. So nice thing, I guess, with the live stream is I get to show some debugging issues as well, and debugging methods. All right, so now this makes a lot more sense than the last one. So I haven't changed any code, and it's saying that, yep. So since this is an actor, we need if we go to attach to component, just gonna have to try to explain what's going on with the code, because I was using a code snippet, and I just want to explain what that error is. Here. So since we're working on an actor and we're doing an attach to component, so you could see that it has to be a scene component, which is the parent. And what I was doing is because the code was most likely I've gotten the snippets from my plugin for a component, is instead of this, which is a component, this refers to the current object, which is an actor. We need a scene component, so we're gonna get the root component of that. Sorry, different keyboard. All right, so this get root, I have to remap that, otherwise I keep doing that. All right, so this get root component, and let's just double check. So this is still oddly but Guess it hasn't compiled properly, but this should compile. Shoulda, would've, could've. Good, this should. Yep. So that's good. So IntelliSense is a bit slack sometimes. All right, so we've built. Let's just open up the project. So since we're building not from the plugin, but an actual class from the project, we should do hot reload. It was just that we had problems earlier on the first part of the stream. So just gonna open that and wait. I'm gonna grab and sip my coffee. All right, so live streaming is a bit different from recording a video where you can have the luxury of editing stuff and making things shorter. But this is easier, I guess, because you just have to talk your way through it and you don't have to worry about editing it after post recording. So, well, let's see how it goes. Need to review the first one, which was a nightmare a bit. Yeah, we tried to do a compile. The compile takes too long. Tried to run Paragon to play while waiting for the compile, and that didn't work. So, teething issues with live stream. I've also moved my connection now from my Wi-Fi to LAN cable. I still haven't moved the stream to a different PC, but because I've got everything set up here, and I just kind of want to get through this one. All right, so Unreal is humming along in there. Let's see what we have. So we're still on the first one. Should be fairly simple. So yep, so we've created an actor that will act as a target, and we're basically now just defining the outer shell mesh for that. So we've created a property for outer shell, inner shell, and a material interface to so the users, Blueprint users, can define the materials for both outer and inner. Yep, and all we've done so far is at begin play, we're getting the we're checking if there is a valid outer shell static mesh defined. If there is, then we set it, dynamically create during runtime a static mesh component, attach it to this actor, set all of these settings up like movable, collisions, etc., and set the material for it. And yep, so beautiful. We have to compile shaders. Yep. So now we have this test map here, and we can then have a quick look at our C++ classes. So we have an A target. So we create a let's create a blueprint out of that one, and let's do it properly. Normally I would have done all my subfolders beforehand, but and then place some dummy files in there, but okay. What do we do? So as I mentioned, I'm following Alora's style guide, so I'll have something under placeables, I guess, and do that. So create one from here, and what do we call it? Create a BP out of that target C++ target class. And just to show you what happens then, I'm going to snap that in. All right, and here is what we've done in C++, which is basically set up meshes here. Do I have some sample meshes? No. Let's use some from the engine. So you just do this, show engine content. There should be a, should we use a sphere or a cube? Cube. All right, so just gonna use a cube there, and okay, the scaling would be wrong for this. Let's have a look. That's fine. Cube. Oh, sorry. Let's make that different. Let's make that a sphere. Oops. Or let's not put anything. So we will have two types of this. So one target, maybe, all right, we'll add a function to kind of generate, randomly generate whether it would have an inner shell or an out, or only an outer shell as part of the game mechanic that we just wrote up earlier. And we'll just put up a material here. We might get warnings because of that. But no, not really, because we're dynamically generating it. For the materials, let's remove the engine content. I just want to see all my white boxing. Ooh. Show engine, show plugin, content. Yep. So we're gonna use a, what do we call it? Blue, I guess. No, we're using blue. Let's use cyan. All right, so pretty much simple stuff at the moment. Can't see anything here, obviously, but simulate should have something like that. So we have a cube that we can, that glows, that we can put on the scene, which will be acting as our target. You can drag it onto the scene, obviously, and let's have a look at it inside VR. See how that goes. Where is it? Oh, there you go. Look. Yeah, it should be visible. All right, so let's have a look. Yep. Hello, that's a huge cube. Get our hands back again, and yep. Right, we haven't done any movement mechanic. I think for this game, we might not need to. We'll do a sitting because I'm sitting, and I really don't want to do a lot of hardcore movement mechanic for this game jam, because I just want to go through some of the things that I might go through on my VR tutorials. So just trying to structure this stream a little bit. All right, so I guess that's good. All right, so that's our target actor, and we actually haven't finished there. So we've got an outer shell component. So now that we verify that everything works, we're gonna do the same thing for the inner shell. So at event begin play, I want a inner shell to be created. So then the task is quite simple. We just create the actor's inner shell, change all the outer to inner. Maybe do search and replace, but should not be difficult to. Yeah, search and replace. If I use an underscore, I could have double clicked. Anyways, it's kind of relaxing. All right. So just make sure everything's right in the shell. Alrighty, so we got outer shell, we got an inner shell. Okay, save, build, another test. So how reload? So I could have also built from here, from the engine itself. And you should see, oh, we missed it. You should see the output log. Oh, message log. All right, so we've got it built. And now, if we go back to here, read any lock, we should see the, oops. We should see nothing. Am I on the right? Oh yeah, sorry. Let's go to the base actor. Oh, actually, we should have that in there. Am I on the right thing? What looks fine? Placeables, BP target. That seems fine. Is it a target? This is the parent class. Too much changes. That's a bit strange. Could be a 418 issue. Really strange. Seem to have lost my properties somehow. How is unknown. It all looks good. Let's have a look. I haven't actually changed much. Just added the inner shell. Added the U properties are in public, so they should be public. Shouldn't have to restart. Maybe we have to go back to 417 to see if this is a bug engine. Because that all looks good. Let's see if the simulation still works. It does still work. But it seems that we've kind of lost the ability to, I lost all my properties. Let's see what a restart does. That's not normal behavior. Interesting. Oh, okay. So I think I know what's going on. I've switched to the binary build, but I didn't do the regeneration of these studio files, and my neighbor has just started drilling their wall. So beautiful. All right, so that's why the hot reload didn't also work properly, and that looks good now. Okay, so that was my bad. All right, so some teething problems there, and we have that cube, simple glow, and now we could do an inner mesh as well. Let's set this. So we need to test that. I know it's fairly simple, so you don't need to test, but kind of just show you. I use a hand and the inner shell material to be don't know, this white boxing cyan instead of a glow. Yeah, let's make it a cone. So I'm gonna do a show engine content. So inner shell cone. Yep. File. Let's do a simulate. Yep. And there you go. So we get the cone. So if we combine them, the cube, and what do we do? Can we do the glow again? I think. Yeah, the scaling, can't see it actually. Not sure if I gave you the glass as well for. No, I didn't, not as a material so you could actually see it. But yeah, so this one here. Let's see. It's from the engine. Nah, not really. Ah, okay, that's for use for the particles. Let's remove all the engine content. And the inner shell. Ah, I've got my wireframe. So I'll make the outer shell. I just kind of want to show you that there's something inside there. Could also do the scale, but wireframe. So I've got my wireframe material from my plugin, and the inner shell would be white boxing cyan. That should do. Same there. Yep. So now you can see a cube and a cone right inside it. Let me do the wireframe as well. Nah, we'll keep it that way. All right, so yeah. Did I put a, yep. If we do that, we should see, I'm just gonna move my headset like this. Oh, do that. That looks good. Okay, so what we've done so far is just create an actor which would act as our target. Have that actor with 2 meshes and 2 different materials, and we can do some more fun with that basic setup. And now we'll see what we have on the list. Sorry. Okay. All right, let's enable the gaze component in the project. So, okay, so now I'm gonna add my gaze component from my plugin. Oops, sorry. It would help if I add it to the pawn, right? So this is the pawn that we're using. I'm gonna add a gaze component to the pawn. Just do that, VR gaze, and we'll attach it to the camera. So the gaze component needs to be attached to the camera because it uses that as a reference point for locations of where to start the ray trace. All right, so we have a front gaze variable, so we've set up here. We will use a beam mesh. Oh no, sorry, that's a target. Ooh, what do we use as a target? Use a cube. Cube. What haven't we used? A sphere. So it is a sphere. Where is the sphere? Come on, baby. Give me a sphere. Yep, there you go. So I have a sphere. And we'll use red for this. So sometimes all this engine content is useful, sometimes it's not. So we'll have a red in there, kind of indicate the target that we have. Target scale 3D collision type. What did we set it? Oh, I think we set it as a physics body, right? So no, all dynamic. Can use that. All right, so we have target scale 3D. Actually, we can have a quick look what the collision was. Oh. Sorry, I'm just gonna have a look at the collision. So I gotta move it and collision query physics. Yep, that's fine. What are we doing? We have the gaze. All right, so let's make it a tad bit smaller. Oh. That. Doesn't matter at the moment because it's a sphere, but could be useful when we change it later on. So we'll have a target tag. That's it, and let's have this. So what the mechanic we're doing is kind of like if you've seen Cyclops, if you missed the first part of this first live stream, we have I'm making something like a Cyclops from the X-Men type mechanic where you shoot a laser using your head, using your eyes. So where are we? Okay, I lost track. Yeah, so I'm gonna put a tag on this actor. Not a component tag, but an actor tag, and we do target. All right, that's it. Or what are you using on? We can have a look. So nice thing with open source and a plug for the open source stuff is you can always, of course, look at the source code. As far as I could recall, I've made that to look for actor tags only, not component tags. So where is my tag? Not possible. Okay, so it is an actor tag. Although I'm seeing here, why am I not using it? Because there has to be a tag, right? And then valid low level, set the material, target dash one, gaze current duration, and we do a gaze hit. Let's just have to have a quick look at that. Must be a bug on my thing, but let's see. Let's try it first. Might be something I missed. Oops. Using a headphone, so I'm gonna have to remove it. Okay, let's draw a debug line on that one. Alright, so debug. What am I doing? Oh, we haven't actually begun the. So normally I'd like to remove all those things. It's default stuff. And at begin play, we probably won't have it at begin play for the entire game because we'd want to use the hand to kind of initiate the gaze. So let's do start gaze. Do a gaze range of 1000. Let's make it really long. Gaze duration. Okay, we can tweak that at some point. For now, we just have a look. Yep. All right, so that's working. Okay. So that line you see there, can you see it? Let me take off my headset quickly so that I'm sure that it's previewing on the screen. Yep. So that thing you see there is a debug line, and I'm happy that this is for 18, the latest version from the GitHub repo, and it looks like they've fixed the issue with stereo debug lines not working properly in the headset, where you have a black line, but now it's looking as good as the one on the preview there. All right, so that's good. So that's us targeting it whenever we look at it, and then when we hit it, we're gonna hit. All right, I really need the camera so you can see my hands. Anyways, what I'm doing is I want to kind of have a laser, kind of like this laser that you see here on top of my head. It looks like it's coming from the top of my head, but the trace is actually coming from the middle part of my headset. I just didn't put the debug line from there because otherwise people will get cross-eyed when they do these tests. Yeah, but I want to have it on the four corners of the headset with four lasers and kind of shooting down the target there. Okay, so I'm now kind of missing my movement mechanics, so I can kind of fly and have a quick look through. But yeah, so that's it. And we might want to add some sounds in there. Yep, so it's looking pretty good. And accuracy is good. So that's the gaze component, how can be used. So let's kind of complete that cycle. So we've got the gaze, and we're starting the gaze, and we have, what do we do? So for the gaze is, I've exposed a couple of delegate events. How to do that is in Unreal, is you open up delegates. Oops, that's my header file. Yep, so added a multicast delegate and kind of returning some signatures there. So I'll see if I can introduce something into the code base for our project here on a game jam, so that I have time to explain that. But for now, that's how I'm doing the gaze and exposing some events in there. And yep, so on gaze hit, I'm doing a broadcast. So once this is true, this gets a proper hit, we do a VR gaze. It gives me the hit, everything that was hit, and the all information about the stuff that we've just hit in the scene. And the percent active is convenience float for you, where how, depending on how long this target duration is and how long you've been gazing on that target, it'll give you the percentage. So this always gets called every time you're gazing at the correct target, and it gives you a constant feed for the percent active. So you could check if you, for example, if we want to only do something after we've hit that correctly, then we like if we do 100% or greater than 100% hitting that actor, then we want it to do something. Then you could do something simple like this. Oh, really have to change that. Keyword mapping, greater to 100, and then you do a branch. Yep. So greater than equal to 100 probably is better. Yep. And then you specify what you want. So let's actually do that. Let's gaze it. So it's a struct. Just gonna expose all of the values for that. And we're gonna have the actor here. We can do a test for the actor, but we're not gonna do that because I'm pretty sure that it will return an actor just because I coded it in C++. But I guess for purposes of tutorials like this, it's always good to have a, and since we're returning a hit, but just so that I kind of say it, do a valid check. It's always nice to do a valid check, just to make sure that you don't get any errors or crashes in your game or experience. All right, so it's completely unnecessary for this, but it's gonna show that. And if it's valid, what are we gonna do? Trying to decide. Because it's an actor and we've got some of the components as dynamically generated, we probably, all right, so I'm now okay, so in live stream, how do you do this? I'm now thinking of kind of what I'm gonna do in the next set, but yeah, we're gonna have to create something on the C++ end, because I made the values for the static mesh components private, so I should, I think, make that public so I can access that and easily access that, and then be able to do some manipulations on it later on. So that's something we need to do for this test. Well, let's just do something simple then. So we're not gonna do, well, let's do print. Sorry, my head is doing a multitask thing. Ooh, that's new. What's that? So 418, they have this now. Development only. Awesome. That looks good. So in the current version of the engine in 417, I believe that's not there. So we're just gonna do a print string to I hit a target. Yay. I hit a target. I marked the target. Mark. Let's keep it a team. All right, and Control W to duplicate that, and here is to just show you what's happening. So if float is less than, so I hit a target. Yeah. So we hit a target, but we haven't kind of hit it at the right amount of time. And this is when we've hit it on the right amount of time. And I believe that's a float. So I should have got it like this one. Yep, 0.99. And we can have a test. Let's have a play. So hit the target, yay. Don't know if you can read that. I marked the target, yay. And then that'll be a good time to stop the gaze mechanic as well. Hit a target. Yay. So see, it's not gonna do anything. It's gonna reset the timer when you do this. So if you want to use a gaze component, that's all pre-configured for you. So just at some point. Yep, I marked the target. Cool. So that seems to be working, and we'll keep it that way for now while we do the development and prototyping of this game. This wave shooter of sorts. All right, so making some progress here. Oh, it's not really that complex. We have laser so far. So we've got laser mechanic. So we enabled the gaze component. We've done that. We found out some issues. Yep, I think from here, found out some issues that we need to rectify. So I'm just gonna add it to my to-do list. What did we find out? Expose static mesh component for BP. All right, so then we can manipulate some stuff in the print, and here we probably would want to suppose scale, do some scale. Okay, we can do that on the polish or later on. Yep, and laser mechanic, what do we do? Yep, so right now will be a good time to actually do a commit. So commit often, commit early, as they say in Agile. So stage, see if I'm in the right place. Yep, and what have we done? Gaze stuff. I should really put better commit stuff, but we're in a live stream. I don't want too much dead air thinking about things. So that's done, and then I'm gonna push it to the remote repo. So committing it local, and of course that was helpful. I don't know what it means. So first time I'm using git kraken, and doesn't seem to give you a very helpful error message. What does that mean? Pre-push failed. Exit code 2. Where do you see the logs on this? Okay, what would cause a git issue? Port push. Let's see if that. So we could see that our master The remote repo is there, but oh, why do we still have one thing now? Okay, then why is that? We're gonna reload it just to see. Might need to switch back to source tree if GitKraken keeps giving me issues. Just gonna push. Oh, there it is. We'll look up. Ah, permission denied. Why? I was just able to push a while ago, so it's strange. Don't want to do a lot of. Let's have a look. So I guess for this troubleshooting. There. We should have. Let's do this. Shouldn't have any issues with this. We will move to source tree. Permission denied. Public key exit. Ah. Oh, okay. Consider disabling. Does not support LFS locking API. That's not true. Because we have GitHub supports locking and we're not even using it anyway, so why is GitKraken complaining about this? Let's have a look. So I think we need to go to the command line. Let's have a look. I guess it's fairly new, the LFS for GitKraken, so it must think. I'm not sure how to enable locking actually in GitHub, and I don't actually want to do it for this project. I will do. Let's do it this way. Where's my quick access? Stream projects. Is that it? Yep. Alright, so all for local repos are here. Why is that saying change? Oh. I'm just bad to see. What? Alright, so we're just gonna go to Old Faithful here. But I don't want to open that now. All right. And we're going to push to master. Let's see if he has the same issues. Oh, here we can see this looks right. So I've just updated GitKraken last night, so it could be. And I noticed that they have this new LFS thing on their end. So possibly not working properly on GitKraken, so we'll just stick to source tree. I thought I might as well try to see what the fuss was about with GitKraken. But so far I've had issues with it, especially with the Unreal Engine. So it's quite a huge repository when I was doing some compilations and merges between release and 4.18. And I couldn't handle it quite as well as source tree for some reason. So I guess I'm not gonna switch to GitKraken anytime soon. All right, so yep, so we've now have it safely stowed away both locally and remotely. So, oh, I've stopped holding the mic. I hope you can still hear me. And if we go back here, I should have everything in there. So this shouldn't have anything. Yep, that's good. So we have that in there. And if we go back to this is the plugin only repository. And then I should, right, so that's, I haven't pushed anything for the plugin changes, including the new branch that we've made. So let's just do that before I forget. So we're gonna open again, plugins. All right, and now actually don't want the binaries there. Do we? All right, so we have to add a git ignore on plugins. I should actually be explaining what I'm doing. So what I was doing is just having a look. I'm basically have two repositories in one, so which is basically kind of like something you'd want to do in your project. So you have a Git repository for your main project and another repository to hold either my plugin or any other plugin that you may have that you have access to the source via Git, so that you can always just simply update the Git repo on your local one. And so you just pull all the changes and then you automatically get the changes from the developer. So, and that's what I'm doing here. And only difference is I'm creating my own branch, of course, for this demo and live stream. And so what I've done is I've added it here, but I'm guessing that my git ignore doesn't have the correct git ignores for Unreal. Yeah. So, and the reason for that is I didn't want to, I guess, for my plugin. I wanted the problem is on I'm using the real one on the repository, and I do want the binaries there for people who don't want to do a compile, and also for the marketplace people, so that they can just grab the binaries from there and then just publish it onto the marketplace. So we should keep that. So I'm gonna have to submit binaries, but I guess for the purpose of the development tutorial for UE, you don't really need the binaries there, because the user should compile it and should help you save space on your repository. So I'm just gonna do, something I might have still forgotten as well is just to make sure, because in Git Kraken we've checked out the correct branch. So yep, so it is correct. So 418 Open Jam 2017. So we just then publish this. Initial build for Open Jam. This really. Okay, so you could, something that I missed in Git Kraken was being able to actually push directly instead of doing it in 2 steps. So I could have just clicked that as well and then immediately pushed. All right, so yep. We've got the plugin and we've got the stuff here for our actual project. And go back and just make sure everything looks good. All right, so some formatting issues, but that's fine. All right. So what do we do next? We've got enable gaze component. All right, so I guess this is fun. We do a laser mechanic. All right, so to do a laser, what I was thinking is, let's open up the pawn. We'll have it from the camera, right? So from the camera, I'm really not liking this blueprint. It's very messy. 1 second, let me just quickly get it up. I really like this addition to the print string node, and I'm guessing most of the other stuff. Okay. Yep. So we have the sword gaze, and what I'm thinking is, so the camera, we're gonna have 4 sources of the laser beam. And now I'm thinking, should I? All right. Yeah, that'll be a good tutorial. I'll create a component here that should attach to a camera, and that component would have the 4 static mesh components. 4 static mesh components. That's will be the source of the laser. So we'll do that. Let's create from C++. You could of course do this in Blueprint, but a lot of efficiency. Even with the nativization, it's really a lot better with C++ for a lot of the stuff, and then you just expose a lot of the functions, convenience functions and stuff to Blueprint users. So it's a nice setup to, and a nice habit to get used to, in my opinion, to have a balance between the two. So I'm gonna have to create a new C++ class. All right, so actor component is a component that attaches to an actor, obviously, and we won't be using this one because this doesn't allow you to attach it to, can't be attached to the different scene components. So you can't attach it to a camera, for example. It will attach solely to the actor itself. So we need to have something that can be attached to other scene components. So we're going to use a scene component as our base class for our component. Okay, don't know why I'm losing my voice. Let me just get some water. Okay, so as you can see here, scene component has a transform and supports attachment, but that's no, and this one doesn't support attachment. So I'm just gonna use that. And what do we call you? We're gonna call this the laser component. Okay. And this time we're gonna expose the static mesh component instead of exposing static mesh and materials. and then dynamically generating them in runtime. Different ways of doing things. So we're gonna do use static mesh component. I will do a uprop first. Add the macro, then have the u static mesh component. Expose that. So laser 1. Okay. Start that first. Build. I could have also built here. But I kind of like seeing this. Alright, so now we should have a laser component, which is, okay. Now we have a laser component that we can attach to here. Should have. There you go, and we have laser. We have that. Which doesn't really do what we want. Okay. Beam. So the material, should have some material here. I tend to use C++ most of the time, but should be able to attach material, shouldn't we? Nah, can't. Alright, so yeah, sometimes this is a problem with blueprint stuff. I lack a little bit of control, so gonna have to do that that beam with the material, or we can expose a property in blueprint and then set that in as our laser material, which is I think better, so we could keep it separate. We'll just do that quickly. So we'll do uprop, and then do a u material interface. I'll find it. Well, sometimes I don't like docents. So pretty sure there's a class called material interface. We'll have the laser. So for the event begin play, what do we want to do? So we want to set the material. If we have a laser material, if we have a laser mat, well, let's do it properly. If we have a laser mat, and if it's a valid laser mat, so valid low level is slower, but we're doing it at event begin play, so that's fine. If laser mat, oops, keyboard, there, yep, it's valid low level, then we will apply that to the static, all static meshes. So laser one, I guess. So if we have that, if laser 1 as well is valid low level, and laser mat should we check? Oh, that's fine. I need my intelligence. Alright, so when intelligence does this, I probably should just build, but just for demo of what you can also do. You could do a from here, see what we have. Use static mesh. There it is. Oh, come on. There. All right. So all of the available properties and functions are here. So I just know where what to look for. But if you don't, you can just have a browse here and have a look of what you want. Because right now we want to change the material, but the material is not part of the component. It's part of the static mesh. So we need to get a static mesh first. And once you have the static mesh component, the static mesh, then you can set a material. And which is what we're going to do, which is get static mesh. Need to remap this static mesh, and then set material to index 0 and whatever material. I think it's called laser mat, right? Yep. And that should be it. So I was a bit blind there, but that should work. Just to build. Okay, so sometimes when intelligence gets to this, that's interesting. Pretty sure it's called new material. Or did I mistype it at times? So that's not exposed, and can't be. Got core minimum. Could be because, let's see, that's very strange. Could have sworn I used that. Maybe not. Alright. Should be talking my way through this, but alright, so it's just got access denied error, so I'm just closing the editor. Try to do a clean build, because somehow material interface is not showing up. Alright, so what else do we need to do? Life marker indicator. Oh, really? Let's just have a quick look at this static mesh. a problem when, ooh, dang. Oh, actually, the static mesh. Sorry, the static mesh. That's actually wrong. The material should be in the static mesh component, not in the static mesh itself. You can get the material from the static mesh, but not set the material. Sorry. Yeah. So. Yeah. So that's sometimes what happens when you lose IntelliSense, and also shows you that you become too dependent on it sometimes. So this is really helpful. The API is kind of remind you of how things are set up and stuff. So we have that there, and we should be able to run that. Yep, because it's static mesh. Pretty sure if we do this, should have all the functions here. You can get the material in there, but you don't have a set material. So you can get the default material that's set on the static mesh, but not on set it on runtime, because you need the component for that. And if you do this, oops. Where's the static mesh component? Seriously, this search is not really that good. This is where I want to be. Okay, so we have set material. No, set material there. It's interesting. That doesn't seem right to me. That looks okay. We don't really need to do this, but just curious on why it's not there. Alright, so if you look at the engine code, so this is more for my curiosity, but the engine code should have the set material in there. Oops. But I've lost my IntelliSense, so I can't quickly show you. the file should have that as a public function. Just a bit interested. Okay, I know what it is. So the set material is not defined in that part, so it's in the UMesh component. Okay. It's not there as well. Parent component for it. Can get there it is. So there it is. So it's derived from the mesh component. So everything here, which makes sense. All right. So just wondering why can't see it in there, but yeah. So kind of just shows you a little bit of if you're wondering about things or trying to figure out how things are meshed together, because sometimes you know, you tend to use something over and over again, like code like this, and sometimes it's interesting to see how it's all set up by the engine, so you kind of can see where you've gone wrong, or in cases like this where IntelliSense fails you, you kind of try to make sense of why things were missing, like the function. But of course, it's a derived class from UMesh, U-static mesh, UMesh component, where we actually have that function defined, and that's where we're getting it from here. All right. So things you don't kind of hidden away from you from Blueprint, but very interesting to know, and maybe not this fundamental, but sometimes things change on this level as well. So at least for the VR headset classes, this have changed quite a bit in the different iterations of the engine. So it's also nice to know all of these things of how the internal engine works and how things are done, and so that when you get into issues or trouble like this, not like this, it's not really trouble, but it's more curiosity. When you get into trouble with things you can't understand, it's easy to look at the engine code, the API, and kind of juggle and see what's actually going on, which is what I really like with the Unreal Engine. So everything's open, and you could actually see what's going on. And if there's, and it is not unlikely that you would find some errors or bugs, and yeah, then you can either fix it or report it to them, and then do a workaround on your end if you can't wait for a proper fix, or if you don't actually. Sometimes when you're working on a project, you don't want to actually do too much engine debugging or engine fixing if you're on a tight deadline. But anyways, so that was just a quick sidetrack onto looking at juggling between engine source code, API, looking at your current source code and see issues. And that was actually quite nice to have IntelliSense fail on me as usual. And we can have a peek through. I can kind of talk through some of the issues or things like that you might encounter when doing development in C++ for UE. All right, so we have, what have we done? We have done under replaceables, under classes. We've now got a laser component, and if we open up the pawn, have that there. All right, so we've got gaze, we've got laser, and the laser we've defined an SM beam, and then I could now use this beam kind of like the way I do my teleport beam, and then scale this beam through into the world, and that will act like our laser. And since we're not doing much into it at the moment, but simply just attaching it to the camera, so this is not gonna work as well as we want to. And we're setting, basically what we've done here is set that material, and we're gonna do 4 of them. But I kind of want to see how Blueprint handles this. So we have a laser, we have 4 static mesh components. Issue with this is we don't have direct control on the component itself. So we'd want to expose variables such as rotation and location for it. Location offsets. Yep. And so I'm just thinking my way through this. And we'd probably want to create an array of 4 lasers instead of doing laser 1, laser 2, laser 3, laser 4. So make things nice and compact. Do we need to? Yeah. We could also do a struct where we have a struct, an array of a struct, where we have laser and all of the stuff about that laser, so we can compartmentalize it properly. And it might be good for a tutorial like this. So let's just do that. So we'll create a struct. So I hope I haven't bored anyone through this. But alright, so we're gonna do a uStruct, and I should have a snippet of that. I'm too lazy to actually try to remember things. 9. Where are you? Yep, there it is. So uStruct. I could have just typed it as well, but all right. So uStruct. So we're gonna use another macro from Unreal, and we're gonna name this. What do we name you? Laser. F laser. Right. And we have the property. What do we need from here? So we're now doing in development what we call refactoring. So I'm just refactoring this quickly. So I have this inside a struct. Just make that nice and clean. And we called it laser beam. And then we're going to create an array of this. Okay, so, but since this is a reference to a memory location, it's fine that it's in the struct. So we have laser beam, we have material. We want the material in there. Okay. Laser beam, their material. All right. So laser beam, laser material. What else do we have? Let's call it laser mesh. And I'm really loving this keyboard. Streaming keyboard. Seriously, where is my semicolon? Oh no, I've changed the UK keyboard. Yep, there it is. Yep. All right. So U material interface there. Laser material. And then what else? So we want the location and we want, well, at least I want to be able to change the location and rotation of it, or have an offset really. So I'm going to do another U property, and we do an F vector to location offset, right? And then we'll do so we have location and then we'll have rotation. So F rotator, and we'll have a rotation offset. There you go. So we have a location offset, we have a rotation offset, and that's that. And then we have something called laser. We'll create a TRA of a template. Now I can't find the thing there. TRA of F laser. We call it laser beams, right? There you go. And on here, Of course, that will invalidate this. We'll loop through that laser beams. So let's just convert that to 32 length laser beams dot num, I guess. So that num in Unreal, so the array, the length of the array for Unreal T arrays. What do we do now? So we do laser beams. We'll do what we've done here. So let's just be lazy. Put that in there. And instead of laser 1, we'll do Alt. Where are my square brackets in this keyboard? Okay. Sorry, this keyboard I don't normally use, as well as this machine. Where are the square brackets in the German keyboard? It's 8 and 9, right? So 9? Yeah. Yep, there you go. Laser 1. And they're not shown on this keyboard because this is like, you can't see the keyboard I'm using, but it's a German keyboard. I'm with a Macintosh style. Why I have this, long story, but I'm using a Windows machine, obviously. So, of course, we'll do the index there instead of 1. Index there, and I guess the material should match up. Did we put that on the struct as well? Laser, what did we call it? Laser material. We call it laser material, right? Yep. That is correct. It's just that my parsing, Visual Studio hasn't parsed it correctly yet. So I'm getting all of these red things, which can be annoying. But the code is correct, so we have that. Oh, why am I fixing this part? There you go. So laser material, laser, set the material. So we basically just refactored that laser beam to be 4 lasers. And then at event begin play set the material that we specified. With yeah, let's just do that as well. So we've done, okay, so since this is my first live stream, I'm trying to kind of structure it a bit, but it's really difficult when you're doing live coding because I know what I want to do and how I want to proceed with it, but it's so organic. All right, so what we have is I've got a location offset and rotation offset, right? And I want to apply that location, the material, the location offset, and the rotation offset as well, if there is a laser and there's a material. And does that make sense? I guess it does, because I always want to have material there. And the only reason this would not work is if there's no static mesh and there's no material specified. And since I'm the only one using this code, it doesn't really matter, because I could just remember it. But if I was doing this for a normal project, I probably wouldn't do this part, the laser check for the laser material. I'll only check for the laser static mesh component if it's available, and then do another if here. Let's just show that anyways. Let's do it properly, although it does take longer. So we do another if, and if this is, let me see how I've structured it again. Yep, this laser material I is valid low level, right? If it's valid, then we set. If you don't do that, the problem is that you might get a crash if you forget to set the material. So, and it's a good place for a comment. set the laser material if available. Iterate through all laser beams and set custom properties. All right, so that's what we're doing, and set that material. And now we're going to do set orientation, position and orientation offsets. So maybe I should do some pre-planning on it for future streams. So this would look better, but anyways, we've got there. So we don't really need to do a null check for floats, so that's fine. We're gonna set the laser eye, and don't want to type those square brackets again with this keyboard. And do that laser eye. What do we do? So, oops, see. I have to seriously remap that. Okay, so we have. So you can see that C++ wasn't meant for German keyboards. Alright, so laser eye, we have set. Problem is I don't have. From memory, it would be add rotation. We could do we could do it from transform and then have a scale. Okay, I forgot. We can do a transform. So instead of location offset and rotation offset, we will do a transform. So let me just explain that quickly. So I could have done this f vector and then scale offset, scale 3D offset, right? So we can control the laser beam's location and rotation, which is something that I would most likely be doing, and not the scale. But it could be possible that I want to redesign that mesh. And for the purposes of this tutorial stream, I'm just going to show it. So we've got location offset, rotation offset, and scale. And that makes, in Unreal, called transform, which has two vectors, which is scale and location, and a rotation. So I'm just going to call it transform offset. And instead of 3 properties or 2, we get just a 1. Right, so we'll do there. It's so from here, set transform offsets. Any luck here? No. We have. I don't understand why that works. It's funny. Add. Can you add a transform? Yep. Add local transform. And so if my IntelliSense somehow my IntelliSense works with a dash, but not with a proper arrow. But if that didn't work, what I would have done is again looked at the API and just quickly show you how to do that. Let's go back. What were we manipulating? Static mesh component. So it's easy now. Go here, and then I'm just gonna do a transform check, and then maybe do set local transform. Okay, so I guess it's in the primitive component, or is it seen? But we'll see. Okay, so it's in the scene component. Yep, so there you go. So you gotta add local transform from the scene component class, and of course it goes down to its subclass, which is RU primitive, I guess. No, So the scene component, and then the U static mesh component. We have a U mesh component, and then a U static mesh component. Yep, and so we have that available in there, and that's why IntelliSense is nice. You don't have to remember this. From memory, I got the add local transform a little bit from memory, and you get used to it after a while, but that's how you can fiddle around. And it's also a good thing if you do that, just because then you get used a little bit to this, to the architecture of the engine, and forces you to kind of have a look at where things are and how things are set up. And then your future projects gets a bit faster. So I'll try to do as much of that as possible throughout this stream. It'll slow me down, but I guess that's the purpose of this stream. So I'll try to do that instead of trying to make the game quicker or faster. So now we have add local transform. It would be nice if I could see the thing. And now we have, since now we go to components, you go back to scene, and then you go to add local transform, not the bookmark. So normally I do that local rotation and stuff. So you can see you have to put a const of the delta transform, which we have, and we won't want that. Might need this. I wonder if I can put a null in there. Let's see. All right, so we have add local transform, and go back. The transform delta is what we call, what do we call it? Transform offset. Transform offset, isn't it? Nope. It is transform offset, so I'm not sure what that's. So we have transform offset. We want a sweep. Nope, perhaps not. And let's see. Not a good idea, but try. E teleport type. So we're not going to teleport physics. And to syncing, I shouldn't be teaching bad code. What do we need there instead of the null? If hit result. Hit result. We'll just define that in there. And there. So yeah. Transform. These are undeclared identifier. Why? Oh, sorry. I'm doing a struct, so should have been this. This. That. And that's wrong. Oh, now I have to type that thing again. Yep. Sorry, copy that. And that, all right. And of course that too. That's done. And that. Fast. Missed that. Okay. All right, because the array is a struct, so instead of directly the property, And that should compile with any lock. Oops, sorry. This mouse thing. Is it not? Am I washing this? No. Oh, called it laser mesh. I think I'm too relaxed. The problem is having to speak while to do this, so. Can't seem to speak while thinking and then writing code and then thinking. But okay. Alright, so this is possibly my fault. Okay. I actually want to see if I can do a null pointer there. If I do a null pointer, there might crash. What does it use it for? It's a reference, right? So, oh, it's an out. That's interesting. So, because it's an out, we can actually use null there, which is the same with what I've just done here. We need to set it up. That means I have to create one. And with that, bloody what is that? That means there's a crash. We won't use that then. There's a default constructor. I just do it like this because we're never going to use it. At least I don't see myself using it at the moment. Yeah. Do that. Or should I be using that for something? I'm thinking. Let's look at properties. The hit result would show me the actors, but I already know that. And I already have the properties. I don't need any of this. At least on this part of the code, I don't think so. What? I need to create an address then. But we don't really need all of these things. Let's see if we can get away with that. Otherwise I can just start typing it. Yeah, not the best way, but I'm just thinking my way through it. I could set up an out variable for the hit result and use the address of that to point it to here. But I'm just thinking there's really no reason that I think of at the moment with this game that I would need it at this point at begin play for anything. So I think that's fine. Yep, okay, that's fine. We'll use it that way. And let's see. So the hot reload should have worked. And I should now have nothing. Did we expose that? No, probably not. We've got a blueprint type. Ooh, I have forgotten something. So we have the laser component. This is all good. So, oh, where did I up? Okay, so I forgot a U property here. There you go. So, and I think I should have, yep, there it is. So that should be fine. So now we have all of that in there. And I'm getting sleepy. God, it's 2 o'clock. All right, so we've got that jump on. Yeah, there you go. So now we could add a laser beam. We could add multiple laser beams. And the nice thing about this setup is we have full control on the laser beam. We have it all nicely set up like this. So you can have different meshes and stuff for your... I'm sure we're not going to use it for this project, but I just kind of want to show you that technique. And then the laser material. And then we have a transform offset, which has a location, rotation, and scale. It kind of gives you a lot of control in there. So let's look at the plugin content. Why is my beam not showing up? Oh, set the material. Let's use wireframe for now. Okay. And my laser mesh is keyboard, come on. Sorry. We have the static mesh component, right? Come on, baby. Then we set the material. Okay, we could have set the material. No, we don't. We can't. Actually, we can from here. We can set the static mesh from here, set the beam there, and set the material there. So now we have that, and transform offset, and that. And fortunately, it doesn't seem to be a way to kind of just copy that through. All right, and then we'll start with one laser beam, and then we can work from there and just see if it works first, and then we could just easily add stuff in. So we scale it at the x-axis to 100, and then we just have to do a preview and see how it goes for the laser. We'll of course create a function to scale this nice and even. So what do we do? So let's make that material a little bit more. Do it the glow. Get a glowing laser. And then that's it. So from the camera we should have, okay, where's that coming from? That's coming from the pawn location. That's strange. Let's have a look at it from the headset. So where's my hand? So I guess it's above my head, which is a bit strange because I've attached it to my... Alright, so this is a good point to show you some debugging stuff. I think 418 you're allowed to do this. In 417 you're not. But in 4... So let's see where that... Okay, so it's coming from the ground, right here. Guess that is correct because the camera is there at the moment for this one. And I guess when I place the headset in, It was actually there, but I couldn't see it because it's right in front of my face. I bet. Let's do a location offset to maybe to the y-axis, maybe 25. Put on the right eye. Okay, can't see anything. It's interesting. Why is it coming up from there? Let's just see if that works. To simulate and see where it ends up. Just at the camera. Possibly out of view. Set that to 10. Yep, that looks okay. I'm not seeing it on a headset. So that tells me there's something wrong with the location. Okay, that still looks good. But why aren't you showing up, mister? Let's do an X offset too. And then they do a rotation to see what bit, so 100, no, 90. So we'll have it parallel to us. Yep. So possibly out of the field of view. Or just not really showing up. Okay, so stay on down. Oh, we rotated it by 90. So now we have to do -10. And then I got it 100 on the Z. Should show us the thing in the headset. Still not quite there. Okay, that should be good enough to see. Alright, so a bit more debugging. So I can't see it from the headset. I can see it in Simulate. So let's just try to figure out what's happening with that component and why it's not appearing, right? So it's actually a good example of debugging. So I Alt-Tab to the thing. And because we're doing generating things from runtime, we actually want to see what's going on there. So from the pawn, what is happening with you? Onto the laser. We should see something. Nay. That looks okay. I can't seem to see the subcomponents from here, which I was hoping to see. So what we do? So the laser is somewhere there. Let's just set the material to something else. So let's see. There's some mesh materials. Should have set it to red. Something red. Or is it too thin? I can't even see it. It's not possible, but let's try to increase the width a little bit. So there you go. Must be there somewhere. It's coming up on the simulate property, so it is there. Oh. So we got that, maybe. Let's try something. So let me get from my content. Could be my mesh. Could be extremely small. Let's scale that beam. So what I'm doing is I'm just dragging the base mesh that I'm using and just checking if it's actually there, but I can't just see it. Then we'll rotate it by 90. We'll set it up with the same width and then see if we can actually see that. Alright, so that we can see, right? So it's not a problem with the mesh itself. We'll just keep it that for troubleshooting. So the problem is the automatic generation of it. So I'm generating it from there, which looks good. This doesn't seem right. So we'll do that. I wonder. I will look at the code again. So we have material. And it's working on the simulate, but it's not showing properly on to the headset for some weird reason. And at the moment we're not automatically generating it, so the static mesh component is there. Okay, so that's an assumption. I guess on the editor we have the static mesh component, but during runtime we don't have the static mesh component in there, and that's causing the issue. I was hoping we could make it easier, but then we have to re-strategize then. So problem is, and I betcha in editor mode it will be there. Yep. So the exposing of the static mesh component directly, because normally I do things stuff like this from C++, but I was hoping I could just expose the mesh component itself, and then we could get some convenience functions out of it. So the problem is it will work in editor, but not during runtime, and especially not during VR preview. So what we can do is we go back to the way I've always done it, is to change this to a static mesh, and we generate a static mesh component during runtime. So we have that, and we have that. Then and of course this time now we have to actually do all of the extra code for the static mesh component. So if there's a laser beams there's a laser mesh, then create static mesh component. Oops. And then you do the code. If laser beams I. We call that. Sorry. Yeah. What do we call it? Laser. Let's just do this. The mesh. Laser component. We need to generate a new one, so do it like this. Use static mesh component, laser component. It's going to be a problem. We still need that. I don't want to. I'm just thinking of the resource and the way to structure this properly. So we will need the static mesh. Actually, the static mesh and the material could be the same. We could actually take the static mesh out and the material out and put it as a public property here so that all lasers will use that. Or we could also retain it here, and then we could have different meshes and different materials for all 4 lasers. For this game, we're going to be using just one, but I'm just going to keep it like that for illustration purposes. So do that, and we'll do a new static mesh component. Laser mesh component. So make that part of the array and make this read only. I'm not sure if we can add a read only here with the rest as read and write, but we'll try. Destruct, and then we'll do this visible anywhere. Alright, so we have the mesh component, right? And then that. Then we don't need that. We need this. This check is redundant. We need that. We need that. And this. Then we'll have beam psi, laser mesh. Okay, so we have laser mesh component, actually. Mesh component. Blueprint read only, okay. That shouldn't be read only in C++. So then we just use this for the rest. I think I should change my snippet to not have this by default. Target static mesh. Right. Laser beams material is there, but it needs to be called laser mesh component. Like that. So that's okay. It's really annoying with this zone red thing. Laser mesh component. So attach to component, since this is a component, so this is fine. And that should be it, pretty much. And we're doing it in a loop. I may have missed something, I'm hungry, but let's see. Ich habe Hunger. So, let's see. Of course I forgot something. It's not a member. Oh, what? The mesh component is not a member of. Yes, it is. Oh, that isn't. Problem. Can't trust this red thing. And there's probably one or two more, but let's do that. Mm-hmm. Yep, and that would make sense. Yep, and because I'm doing this, I need to do that. As I've already explained later why that error comes up. All right, so has to be a mesh component because the add local transform is a function derived from the U mesh class, static mesh class. So we have that, and we have should have lift off. Let's see. Now in the headset, I should see the darn thing. This is fun. Except for that one. Let's see what the error is. That's fine. Let's not be scared of that. I need to eat something soon. So come on. It's probably the blueprint. Ah. I was doing a check from here, right? An array from there. Shouldn't be any reason, but let's have a look. Come on, I need to know what caused the crash. So we'll have to wait. Or I could just reread the code, see where I messed up. And deliver laser mesh set material. That looks okay. It's not a pointer, so it should be okay, but should just set it to 0, 0, 0. Oh, I know what it is. Oh, dang. Need to add the debugging symbols. I know what it is, so let's see. Come on. Oh, it should have been caught from this. Let's try that. So VR pawn, we add VR gaze. Nope, laser. It shouldn't have mattered. So I'm doing a check from there. Because is valid low level checks for null. So that wasn't it. Well, I can try and do the beam here. Transform offsets. The laser mesh component is none. Could be because I've made that read only. But I should be able to access that from C++ with that macro, I think. Can be sure. Pretty certain it says blueprint read only. Ah. How do you do edit in C++ only? Should we just not say it? I don't actually even want that in blueprint at all. Right? We don't want that in blueprint at all. So we can just remove that in there. I think. Okay. Yep. material would be cyan glow, simple glow cyan. Let's do simulate again. Yep, that looks looking good. And we have scale to 100. Let's allow ourselves to get cross-eyed. So that's a laser there. Let's try it. Yep. That's looking good, and I'm getting cross-eyed. Inside the headset, but that's outside. That looks fine. And there'll be a laser beam in there. Doesn't look like much now, but we're gonna spiffy it up. So the debug line actually looks better than the actual laser we're doing now. Well, we're gonna put some animation stuff. Not really animation, but just scaling stuff. So we're gonna have 4 of those here, and then just firing a laser towards, yeah, that's another thing. I don't want them to be firing towards from here to the 4 corners. We want them to be firing from there. So we're gonna have to do a rotation of that to point towards the middle of the camera, right? So that's not a big problem. Yep, so we're gonna do that. Just put that in before I forget. So we've done the laser mechanic, so there's still stuff to do. We need to have auto rotation of laser to middle of camera target. It's not too difficult to do, but we'll just write it up. And then of course, after we've done that, we're gonna do the fun stuff, which is auto scaling to target. We probably need to define how we're going to do the target, so we probably need to do the range of the laser. Property for laser range, so how far we can do the laser stuff, and possibly we could connect it with the gaze, right? We probably would want that for this mechanic. Well, we'll do it per iteration. So let's do a simple iteration where we do a property for laser range, and then we kind of target something out of that range, regardless of whether or not we're doing a gaze. I'm not sure if that would actually work better play-wise. We need to play test, but yeah. And then we have to think about how to do the life marker indicator. Maybe we'll just fade the camera to a different color, like red, so the world then turns red or bloody, and then gets really, really red or black or gray until you're dead. If you keep getting hit by the targets, by these waves of targets. Yep, and yeah, then we're gonna do level locking. So still a lot of work to do. A lot of this are just like routine stuff, but something new for me is having to talk my way through it and kind of explain each step of what I'm doing. And I don't know if I've been doing a good job of it at the moment. I may have been skipping too fast, but yeah, I'll try my best for the next one. But I guess for now, we'll continue on to the next stream. Let's see how I feel later tonight, if I want to do some more streaming, but we'll find out. So just keeping this game jam relaxed and just to see how this live streaming goes. And yeah, so far it seems to be okay. It's kind of easy because you don't have to do any editing afterwards. So right now after this, I just have to, well, just stop the stream and that's it. I don't have to do post editing. All right, so thanks, folks, for listening in. If there's anyone listening in, actually, I hope there's none. All of the mistakes. Try not. Well, the debugging is part of it, but yeah. So my first live stream, so be gentle on the comments. All right, thanks, guys, and cheers. I'll find a way to stop the stream. There.